All right, then I think good morning to everyone, good afternoon for those who is in a different time zone. Thank you for joining our session. We're happy to see everyone. We will keep on a video our main speakers today. My name is Olga Hogan. I work for Royal Haskoning, and I'm the host of this session. We have our maritime experts with us today, Bas, Alex, and Kos, and our guest speaker, Michael McGee. So thanks everyone for joining. For your time today, we have a webinar, how to make moored vessel operations safer. And we will have around 45-50 minutes. And we leave some time for questions and answers from our participants. Please use chat if you have some questions along the session. And you can also unmute yourself at the end of the session and ask whenever you find interesting. Andy will take care of answering some during this time. And I think we can start from the agenda. So I will hand over the floor to our first speaker, Bas, and we can move to the agenda.
Thanks, Olga, for this kind introduction, and welcome everyone that I actually cannot see, but I trust you're there, for this opportunity to present how we as a product team deliver actionable insights to the harbor master and the terminal operator in port operations. My name is Bas van Son. I have a background in civil engineering in TU Delft. I've been with HaskoningDHV for some 12 years, and the last few years active in building the bridge between maritime knowledge and the digital world. So first, what we're dealing, I think Olga introduced, so a bit of introduction and the background from my side, a demo by Koos Stubis, my colleague here. We dive into the engine of our product, Smart Mooring, Alex van Dijzen. The voice of the customer, Mike McGee, will give his view from the user, an actual user of our system, and then we have a summary and Q&A. So first, a bit about ourselves to connect a little. You can see a bit of us. We cannot see you, but anyway. But our passion as a team for the topic of water and maritime has been our main driver to build up experience in the field of ship hydrodynamics, so the behavior of moored ships in ports. And we did that mostly for design of key infrastructure, but with the development of the digital era, we thought in 2019, let's untap the potential of that current state and that digital technology, and see whether we can develop an in-house system that does not only look at what is happening now in a port at the real time, but actually can predict the near future. In other words, a system that predicts moored vessel behavior in a port days in advance, and also looks back in history. So to realize this, we built up a system and it tested in the port of Rotterdam for wind, and you see here a picture of our pilot location there, and in Ras Al Khaimah ports, RAK ports in the United Emirates for waves. So both ports became our launching partner at that time in the development, and I'm happy that Captain Michael McGee is present today in this webinar to tell us about his experience with smart mooring in RAK ports. So we expanded our product basically with several early adapters. Besides the Port of Rotterdam, you see the logos on the left. And well, we are ready to serve the maritime sector further. So we'd like to tell you the story. And the nice thing is that while we were engaging with the Harbour Masters community, we really started to realize and learn how challenging the work of the Harbour Master and the port control is. Keeping staff and vessels safe is a massive responsibility, and it requires port operators, port control to see and oversee what is happening in the port. And that is not easy with so many things going on at the same time. Also, the central role, okay, I forgot this slide. The central role of the harbor master is becoming even more challenging. And I think we all know that ships become larger, that storms become heavier and more frequent due to climate change, and that aging and old infrastructure remains in use and really stretches the limits of them. So even in such challenging environments, operational decisions are often based on compiled data and years of experience of the harbor master and well, experienced professionals. But still, those unforeseen conditions can lead to dangerous outcome. And you see on the left a bit of an unforeseen condition, a heavy roll of a vessel, a quick little movie. And mooring lines can fail and cause damage and injury. I think you all know that. Excessive motions of the ships, like you see here, can cause damage to the ship and the port infrastructure and harm the environment and lead to inefficient cargo handling, things like that. And just to mention one very extreme example of what the consequential damage can be in quite a severe case was in 2007 in the port of Rotterdam. A vessel breaking loose, colliding with a jetty, ripping open an oil pipeline and oil flowing into the harbor, with consequential damage, well, in millions of euros in direct cost, environmental impact, and also a reputation issue. And we see these incidents in several ports, in many ports. Well, they're not all out there, but these things happen, and those risks can be mitigated. And we, for example, a cruise vessel breaking loose in France recently, a ferry in the Netherlands drifting and causing damage to ships or port infrastructure, or a container vessel in Canada breaking its couplings. These things happen. And well, before we move to the bridge to what solution we provide for that to mitigate those risks, I think, Olga, you can get one of the questions on the screen.
Yes, let's ask first what is the background of our audience just before this one. So let me see who joined us today and let people answer. Is it maybe port authorities, or is it any ship owners with us? Is it anyone who works in engineering and consulting, or maybe some people from research, or anyone else? Just let us know your field. Please submit your answer. Then we can see who is with us today. So we see, okay, so it's 30% from port authorities, even a few ship owners, and half of our audience actually works in engineering and consulting. So it's good for us to know, right, Bas?
Yeah, no, it's good to indeed. Yeah, there's a bit back from the audience. Okay, next question then. That was actually the bridge, that because this was the upfront question. Now the question that I was actually referring to. Do you experience challenges ensuring safe mooring? Can you put that one on the screen, Olga?
Yeah. So we have a few variants to answer. Maybe they experience yes regularly, a few times per season, maybe once per season, maybe very occasionally, hardly any, or maybe question doesn't apply to the person.
Yes, the question is actually how often do you experience challenges ensuring safe mooring? Yeah. We have some responses.
Yes, so we have around 9% yes regularly, 3% once per season, over 35% a few times per season, 18% very occasionally, and 37% say question doesn't apply, and it's probably because 50% of the audience who joined were from engineering and consulting.
Yeah, that makes sense. Yeah, and kind of what we expected, I would say. And yeah, we see it as well. I mean, it's not all in the media, and which is okay. But if you dive in and you speak to the insurance companies, you see that is a it is an issue out there, and I mean safety first. Well, that's on even on ships. So anyway, let's move on. With the question like, what if there is a system that increases the insight for port control or terminal operations, a practical system that builds on the current level, so the expert judgment, the current level of insight by turning data and engineering know-how into high quality information and insights that actually increase over time because of learnings, because of data, and because of the mix of engineering know-how. So basically, that is actually smart mooring. And smart mooring is a software application that actively warns the port operator or ship or harbor master for expected unsafe situations of a moored ship. What does it do? We predict mooring forces and ship motions days in advance for multiple locations in the port. So we have a port overview. And it's a simple and intuitive, and it combines the the complex dynamics of moored ships with port data and weather forecast. And that you see in this picture, where we take actually the digital twin thought, if that resonates, because we play, let's say, a central role in the middle, where on the left, data flows come in, AIS data, vessel data, wind and wave prediction data, static or dynamic or measurement shore data. That all feeds in our system. We make information out of that. We describe that. We use that to predict on Earth level, also on a port overview level, and that provides the insight with which the harbor master or the port control people, or even a terminal, can prescribe certain actions or be supported in their decisions. With an important thing, and the theme of this webinar, can the vessel be moored safely? So we're in that field, and we like to serve the maritime sector to handle that business question. Now, how that looks, my colleague Koos will take over and demo that. But before we do that, so that's the demo sheet, we have another question. When you expect adverse weather conditions, what do you do? So Koos, can you, in the meantime, while people are answering the question, take over the screen?
Yeah, actually, people can also pick a few answers. So they might use tag assistance, they can use additional lines, they can apply more pretension, or they maybe apply short tension, or they can also reject vessel from the berth if it's too dangerous, or maybe some hope for God's help. I guess those who works in engineering and consulting or somewhere else.
You wanted a joke in, right, Olga? Okay. Yeah, you have to with all those serious engineers. Anyway,
all right. I guess you can share my. You can see my screen, Olga.
Is there an answer to the question? Is there the result from the?
Yes, I'm still looking what people answering. Actually, I see that the most people, 30% and another 30% use tag assistant and additional lines. Also, it's quite often 26% reject vessel from berth. But the other three are very rare. So apply more pretension and apply short tension. Maybe this is something for Alex. Maybe
we'll take it later. Let's go to Koos, also seeing the time.
Yeah. Okay. Yeah. So my name is Koos. Good day, everyone. I'm working for about 5.5 years now for Royal HaskoningDHV. I have a background in hydraulic engineering, and I'm the product owner of Smart Mooring. And I'd like to demo the smart mooring solution by showcasing the environment of the Port of Rotterdam and Portsmouth Port. And maybe first start with this. So the engine underlying the smart mooring solution is based on the results of dynamic mooring analysis. So a dynamic mooring analysis is the simulation of the behavior of a moored vessel in wind or waves or currents. And smart mooring basically unlocks those results of the state-of-the-art simulations in a user-friendly interface. as a digital vessel. And my colleague Alex van Dijs will explain a bit more on those DMAs right after this demo. So what you can see here is the smart mooring solution. Smart mooring currently comes with two modules, the safety prediction module and the vessel clearance module. And this is what you can see here. This is the port overview of the safety prediction module of the Port of Rotterdam. And you can see those dots, those blue dots in this case. And those dots represent berths for which we have configured those digital vessels. So those results of dynamic mooring analyses. And the color of those dots indicate the safety status for that berth for the next 24 hours. So a blue dot basically means that for the next 24 hours, the maximum mooring line forces can expect it to be below the working load limit. So below that criteria for which you can consider the mooring to be safe. The working load limit being, let's say, 50% of the minimum breaking load of the lines, being the capacity of the mooring lines. If those dots would become orange, that would mean that in the next 24 hours, the maximum mooring line forces can be expected to be higher than that working load limit. And red dots would mean that the expected mooring line forces would even exceed the capacity of the mooring lines. So this port overview provides the opportunity to really focus on the most sensitive berths. So what I can do now is I can select a berth. So for example, one of the berths here in the Port of Rotterdam, the second Maasvlakte. And then I go to the berth detail view, the berth detail screen. And what you can see here is a graph that basically shows the mooring line force as a function of time. So it's plotted as a percentage of the minimum breaking load, being the capacity of the mooring line. And on the x-axis, you can see the time. So now you can see the predicted mooring line forces up to 3 days up front. So below this graph, you can see the table providing the forecasted mid-ocean conditions. In this case, the forecasted wind conditions. And so based on those forecasted wind conditions, we come up with predictions of mooring line forces, but also of predictions of vessel motions in all 6 degrees of freedom: surge, sway, heave, yaw, roll, pitch. Everything can be plotted here. In this drop-down menu, you can actually select a digital vessel that has been configured for this specific berth. So this is a container terminal, so we have configured all kinds of container vessel classes. So I can, for example, select the post-new Panamax vessel. And if you want to know what assumptions have been considered in a DMA, you can open the basis of simulations. So the basis of simulations shows one of the most relevant assumptions underlying the dynamic mooring analysis, like the vessel particulars, like the mooring configuration that has been considered in the simulations, the characteristics of the mooring lines, for example. So that is also available here in the tool. That not much because the wind conditions are quite mild. But this viewer provides you also the opportunity to go back in time. So what I can do, for example, is I can go back to February last year when Storm Eunice visited several parts of Western Europe. So that was in around this day. And then you see this view. So you can see that based on the forecasted wind conditions, so mainly southwesterly winds up to like 30, 35 knots, results in significant mooring line forces around the working load limit. But if I would plot the same safety assessment for a loaded container vessel, because this is for a ballasted container vessel, you can also play around with the loading condition. You will see that that would result in even higher mooring line forces due to the larger lateral wind area. So the application provides you the opportunity to see the actual impact of the loading condition, and that the loading condition has a significant impact on the safety status of a moored vessel. The next example will be in the environment of Portsmouth Port. So about 6 weeks ago, Portsmouth Port dealt with significant winds from the west. And what I would like to show here is the impact of the orientation of the key. And for that, I will select the bird number 1, and I will select a medium-size cruise vessel. So this one. And I will go back 6 weeks in time. It was in April, the 11th of April. And what you see here is, well, mooring line forces, expected mooring line forces to even exceed the capacity of the mooring line. So it can be really considered as to be unsafe. However, if I would go to another bird, and if I would select, so I just showed you the predictions for bird number 1. But if I now select bird number 2 with a slightly different key orientation, if I would select the same vessel, so the medium-sized passenger cruise vessel, if I would select the same day, so the 11th of April, you would see mooring line forces even below the working load limit. And so there's a significant impact of the key orientation on the safety status of this moored vessel. So these kind of insights can be provided by smart mooring. So that's in short the safety prediction module. I will quickly go through the vessel clearance module, because that is one of the other modules of smart mooring. And this module is by default available for all ports, for all birds in the port. It's a simplified tool to provide a vessel clearance advice based on the limiting wind speeds for safe mooring, in which we consider both the capacity of the mooring lines, but also the capacity of the bollards. So the safety prediction module was really based on those dynamic mooring analyses. The vessel clearance module is based on a more static analysis, which again is based on industry guidelines, rules of thumb, and expert judgment. So the vessel clearance module comes with a wizard. So in the first step, you can select a berth, for example, this bird, the Albert Johnson key. And with that bird, also the corresponding bollard capacity is being considered in the calculation. So in this case, for example, a 50-ton bollard. You can continue to step 2, in which you can select a vessel. Well, you can retrieve the relevant vessel particulars by entering an IMO number. You can also play around with vessel particulars by selecting a vessel type. You can play around with the most relevant vessel particulars, like the length overall, the deadweight tonnage, displacement, and windage area. And once you have selected a vessel, you can continue to step 3, in which you can play around with some mooring configuration parameters, like the number of breast lines, the number of mooring lines per bollard, and the mooring line capacity, the minimum braking load. And then if you click Finalize Wizard, the application comes with the limiting wind speed for safe mooring. And it's good to mention here that in this vessel clearance module, we only consider off-key wind. All right, so this is the vessel clearance module. So I can tell you a lot more about the smart mooring solution. There's a lot more to show, but due to time, I will leave it here. Bas, can you show your screen? Because I want to show you 2 slides with some features that we are planning to develop in the next quarters.
Yes.
All right, I will go to that same slide. So,
Easy.
Yeah, so some upcoming features that you can expect to be implemented in smart mooring in the upcoming quarters is, for example, the prediction of bollard forces and fender deflection. So I just showed you that we provide predictions of mooring line forces and vessel motions, but we will also unlock predictions of bollard forces and fender deflections. We will also implement the impact of tugs and short tension, for example, so that you can really play around with the number of tugs and to see what is the impact of, for example, 1 or 2 tugs on the expected mooring line forces. We will also add some more configurability of the mooring configurations and the line characteristics. And we will also come up with predictions not only based on forecasted mid-ocean conditions, but also on actual measured wave conditions or wind conditions. Beth, can you go to the next slide? What we will also add to the application is a so-called historical viewer. which provides you an overview of potential unsafe situations in the past. Well, there are a lot more features coming up. These were the most important ones that I wanted to show here. And I think that's it for now. I think we have added a question also here, right, Olga?
Yeah. Yeah, well, people... Olga, go ahead.
Yeah, just launching the question.
Yeah, so I'd just like to come back while people answer this question on one of the previous questions. I think it's interesting to see the result that a lot of people indicated that tuck use is often applied. We hear it a lot, and that is the reason why we are now developing that tuck module, really assessing like what is the effectiveness of a tuck during a storm. Should I have 1, 2, 3 tucks or not at all? And also the choice of that is dependent really on the risk seeking or risk averseness of the user. And in the end, the user is the one taking the real decision. And what smart mooring does is basically provide some science behind that decision and to support that decision. Okay.
Bas, maybe you could share your video as well. So I guess you also see the results of the question if people already use digital solutions to keep vessels moored safely. So only I see that 13% already using some digital solutions and almost 60 not yet.
Okay, yeah. Then the question is what solutions are there, but that's not in the question anyway. I think it's time for to move actually from the application that you just saw and demoed by Koos to the actual engine. And Alex, if you can put on your camera, then we can move to, let's say, the dynamic mooring analysis part. So the engine of smart mooring, and you're sharing your screen. So I will put my camera off. Alex, take the floor.
Yeah, thank you, Bas. I saw some questions too, actually. 2 people asked some questions in the chat, which I think is good to maybe answer after my part. Hopefully they help answering them partly already. My name is Alex van Dijzen. I'm a background in maritime engineering from the Delft University of Technology. I also carried out my PhD at the TU Delft. And for 10 years, I'm working for Royal HaskoningDHV as the leading expert in dynamic mooring analysis or moored ship behavior in port. So, Koos already mentioned, dynamic mooring analysis is the backbone or the engine of smart mooring. And that knowledge, of course, we gained over the years doing maritime projects for design. And now we unlock this experience and expertise in a digital tool to provide actual insight. But I want to show you a little bit more about what is a dynamic mooring analysis and what do we do, what do we get out of it, and which is in the underlying engine of smart mooring. So dynamic mooring analysis is a complex hydrodynamic calculation of the moored vessel behavior in wind or waves. Basically, a moored ship is a mass spring system. So the force is wind or waves or both. The ship is the mass, the displacement, and the spring is the mooring lines and fenders. So this is based, in that sense, basic dynamics that you can excite this mass spring system and you get a response. That brings me to a first comment about dynamic versus static mooring analysis. When we really predict the moored ship behavior in wind and waves, we apply dynamic mooring analysis because Royal HaskoningDHV strongly believes that dynamic mooring analysis is a more accurate description of the physics. I think everybody can imagine in waves induce a time-varying response, which is a dynamic response of the moored ship, but also gusting wind. Wind varies in time. And if you look at the vessels nowadays, which are quite large, container vessels are even larger than this LNG carrier, they respond to the time-varying wind in a dynamic manner, which results in dynamic loads in the lines, which is something we take into consideration and which we model accurately. A static mooring analysis, still widely used in port engineering, assumes a constant current, that's fair, but also assumes a constant wind speed. And if you include waves in the static mooring analysis, it will yield erroneous results. So that's why we, when we really predict the mooring line forces and motions that you see in the smart mooring. It's all based on the dynamic mooring analysis. The software we use to carry out the dynamic mooring analysis, which is embedded in the smart mooring software, is called AnySim and DIFRAC. That's developed by MARIN, the Maritime Research Institute in the Netherlands, which is a renowned research institute with several towing tanks and ocean basins. And we chose that software also to have a partner that we can ask relevant questions to. So it's more a research institute than a commercial software provider. Obviously, we are responsible for the modeling if we use the AnySim and DIFRAC software. And what do we put in the software is, first of all, the vessel characteristics. I will show you some results for this large HMM Algeciras class container vessel, close to 24,000 TEU. Obviously, we have to know the key characteristics. Where are the fenders? What fenders? Where are the bollards? What is their capacity? Then we model mooring configuration and obviously the environment conditions. In this example, it's wind, need to be modeled as well. So here you see, for example, a mooring of this large container vessel, which is a crossed mooring, which is often applied for these vessels. And what is also important is the line material and the minimum breaking load of the line. As you can see here, this is the load elongation curve of the lines, where you see that nylon lines are much softer than, for example, polyester lines or high modulus synthetic fiber lines. So we make choices here that we include in our modeling, and based on that, we show results. Now, what are the results? Then I go to a movie. 1 second. Yes. So this is animation. Yes, there we go. Of a moored container ship in wind, and the wind direction is clearly indicated. Obviously, the ships are located perpendicular to each other for a reason. So the one on the right has off-key wind, and such a large container ship with a large wind area, shows a dynamic response to the gusting wind. The container ship on the left, which is more favorable to the wind direction, similar to what Koos just showed with the cruise vessel. It looks like it doesn't move. It moves obviously a little bit, but the ratio between wind area, mass, and also the mooring is completely different than when you look at the ship on the right. So this is an illustration of how a dynamic mooring analysis looks like, how the moored ship behavior is modeled in the software that we use. 1 second, I go back to this one. So what we get is mooring forces, mooring line forces, and fender deflections and vessel movements. And obviously we have to interpret those results. So here I show you an example of what we how we depict the results. This is the maximum mooring line force in a simulation for off-key wind. So the vessel in animation on the right. And the different bars, the different coloring is increasing wind speed, 16, 18, and 20 meters per second. And the numbering is the line numbering that is the same, are the lines in similar manner as the top view of the mooring arrangement, so from aft to fore. And you clearly see that obviously the maximum mooring line force increase with increasing wind speed. That's why the green bars are the highest. But also you see the different line tensions in the different lines. For example, one of the breast lines, line 4, that shows the largest mooring line force together with the breast lines aft, fore and aft. Now this we can show for multiple direction and multiple wind speeds, and there you get a plot similar to this. It's a so-called polar plot. The orientation of the vessel is also indicated, and the off-key wind, obviously results in the highest mooring line forces. For example, if you look at the green, dark green one, you see that the mooring is still safe for all wind directions because it's only 40 meters per second wind. But if you increase the wind speed to 16 or 80 meters per second, you go to the blue ones, you exceed the red circle, which is the working load limit. And the working load limit is 50% of the minimum breaking load of the lines, which is defined by the Ocean Mooring Equipment Guideline. So this is a top view of all wind directions, all wind speeds, showing you up to what wind speed the mooring is safe, until there is a risk of the mooring line snapping. And this is obviously based on this technology and this insight, based on 150 projects we have carried out in the past. I started working here 10 years ago, and then dynamic mooring analysis really became part of port engineering. But about 20 years ago, 25 years ago, it slowly was introduced when this first software, the commercial software to carry out dynamic mooring analysis became available. And such a polar plot or a bar plot is typically what you get when we provide consultancy service for port design. But smart mooring elevates that to a next level. It combines the result of the state-of-the-art complex dynamic mooring analysis, the complex hydrodynamic calculations, with the weather forecast, wind and waves. And therefore it provides real-time prediction of the mooring safety, like Ko showed, for multiple vessels, multiple loading conditions, for multiple or different locations in the port. So it's in a way, unlocked in a more state-of-the-art manner than when you look at a report. And I guess that was already my part.
Thanks, Alex. And I think people have another question on the screen. What would you use smart mooring for is the question. What you think you could use smart mooring for is also. Oh. And while saying that, indeed, Alex, it's a nice bridge back indeed to the smart mooring software. And let me share my screen. Let me quickly bridge back indeed to where you ended, right? The software, the background that Alex van Dijssen just described is under the booth of smart mooring. You can access it, but you don't necessarily need to see it in the operational setting. And so we validate it, we listen to harbor masters, we listen to port control people, etc., to make sure that we have a user-friendly interface on the front. If you want to dive deeper, you can. And another thing I like to stress, and we didn't mention it earlier in the presentation, is that the part of having specific vessels specifically modeled for your case in your port, that can be done. But we also have a software level where we build industry classes. And they are more, let's say, better value for money. Let's say no, similar, but they are industry standard ships, so digital ships that we built that we can provide. They are representative for a range of ships, but they're not exactly the ship. But if an exact ship needs to be modeled, we can do it. But obviously, there's there's a higher effort involved to do that. But that product thinking has been embedded in smart mooring. I think the question has been answered probably. Is there something we can, a feedback thing before we move on?
Yeah, I think what is interesting that some people has answered that smart mooring can help to automate the mooring process. And actually, it was a quiz question, and it's not right, Bas? We don't automate the mooring process, but we do everything else what is mentioned.
Yeah. So smart mooring is not automating. We're providing the insights that support decision. And smart mooring is basically not hardware, it is software that gives more insight in what's happening out there to support the years of experience of the harbor master and to get that port overview as well. We're factually not automating, but let's not take it too much. Let's focus on our next speaker, because I think it's interesting to hear simply from the field from Mike McGee. And Alex, can you please turn off your camera, and Mike McGee, if you like to show your camera. There you go. Yeah. So thanks, Mike, for joining us, and really appreciate that you are willing to take the time to be with us in the webinar. We've seen a bit of theory, we've seen a bit of introduction, we've seen a demo, but actually people may be most interested to hear like what are actual users saying. So can you please introduce yourself quickly, and then I have a few questions for you.
Okay, Baz, nice to see you, and thanks for organising this. It's been very interesting to listen to. So I'm Captain Michael McGee. I'm the Harbour Master of RAC Ports in the UAE. We handle about 80 million tonnes of bulk products a year. We're the largest bulk port in the Middle East. I have 25 years as a Harbour Master experience, and I've been 8 years in RAC Ports.
Thanks. And well, just to start, like the first question, what made you engage with HaskoningDHV in an early stage of the product's development?
So in 2018, 2019, we built a new berth, and the berth is exposed. The decision was made to build it without a breakwater. All of our ports are actually enclosed behind breakwaters for a reason. Now, we discovered quite quickly that the breakwater, not having a breakwater, was an issue for us. The dynamic mooring analysis we'd done to actually help us with the decision making of whether to build or not build a breakwater indicated that we'd have around about 30 days downtime a year at the berth. Now, the berth is built north-south, and the prevailing conditions are generally from the west. So you can imagine that the conditions will cause vessels to move alongside. Now, so far in the 5 years we've been operating, we have actually had 30 days and 3 hours downtime on average. So the dynamic mooring analysis is pretty accurate. The data that we get is from our weather forecast. Our weather forecasters, Storm Geo, are internationally recognized. They give us a fairly detailed breakdown of the wind waves, the swell waves, combinations, periods, quite a lot of information. We also have a wave buoy, which brings us in a lot of real-time information. And all of that data coming in, we were able to see what was happening and what was likely. But we're interpreting all this manually. And there was so many different dynamics at work that we couldn't quite work out what was the best combination. Ships were rolling, lines were breaking, we were having problems, tugs lines were snatching. It was difficult for us. So we were aware of Royal Haskoning, and we knew about your smart mooring system, but it was only for wind. So we engaged with each other, Baz, and you basically get your team to start working on sea conditions, and as a result, you came up with a product for us that could actually predict the mooring breaking line strain, and as you've shown in the graphs there, that the different conditions that ships would be exposed to alongside. So that is how we got involved with each other at the early stage.
Yeah, thanks. And just to recap, so your case is the wave case, right? So in Rotterdam, in Belfast, etc., and Groningen, on the shields, we have the wind case up and running. I think Koos also showed the wind case in his demo, but yeah, Akports is where we connected the wave case. And you mentioned one of our input providers, the Met Ocean conditions. They come in your case from Storm Geo. And basically for understanding, right, smart mooring goes that step further to translate the weather predictions into ship moored vessel behavior. And so we go one step further than the weather forecast, and that is basically where the added value of smart mooring comes in. And Mike, back to you, because it's about you. Smart mooring, how does it help you on a day-to-day basis? And are there specific moments that stand out that you remember using it? So
the data that comes in, as you've just showed us prior to speaking to me, is that it comes in a graphical format. You can imagine that weather forecasts have lots of tabulated information in, and you really need to know what you're looking at to understand it. And there's a lot of different information on there. Also, our Waveboy gives us all that information as well. So combining those two things is quite actually, you really have to have an eye for it. So having all this, we provide an API from our Waveboy to our forecasters to improve their forecast. They provide information to you and you're making your predictions based on that. So the graph data is actually quite an easy to read format. It's quite simple. It just goes up into the red or the sort of amber zone, and you know that there's going to be some conditions approaching. So on the day-to-day basis, we can provide that information to our operations team. The whole logistics that go behind the loading a ship, of getting the cargo to the berth, of vehicles coming down from the mountains to deliver direct or bringing from our storage areas, that all has to be addressed. So if we can get some advanced warning that there's going to be some difficult conditions coming up that's going to affect ships, we can start working on the whole logistics chain. The operations department can alert the customers and the cargo agents, will alert ship masters and the marine agents. And we can actually send out the graph, a snip of the graph, so everyone knows exactly what it looks like. So on a day-to-day basis, it basically just allows us to read what's coming ahead. Our forecasts go out for 14 days. The accuracy obviously gets better as it gets closer. The smart mooring gives us a reading from 5 days out. So we can alert all the marine community here 5 days before we're expecting any bad weather. So things that stand out are probably, we've had occasions where we've used the system to work out, well, if we choose a Panamax ship, as you showed with that example of the in Portsmouth with the ships on different berths and how they were behaving with the cruise ships, we could put a Panamax ship alongside and it would roll because of the period of the swell, which is around about 6 seconds. If we put a Capesize ship on with a 45, 50 meter beam, it wouldn't roll. So it helps us decide, can we actually put a Capesize on? And we've done it and it worked. And we've done that on several occasions. Other times we will load a ship in the inner harbour to the maximum draft. We can still continue to work in the inner harbour because it's not affected by the swell. And then because of the different stability characteristics of a loaded ship, we can put it onto the deep water berth in certain conditions, which we couldn't do with a ballast vessel. And the system allows us to choose between a ballast, half-laden and fully laden vessel. So the graphs will change according to the loaded condition.
Yeah, I on the screen, I put one of your examples that you showed us quite a while ago already, where you have that Capesize or Panamax decision being supported in the same storm, seeing a heavy impact for Panamax, but a low impact for the Capesize. So that basically gives you tools to support your decision. Is that correct?
Yeah, that's correct.
Yeah. And seeing the storm season going and leaving, etc. How much do you use smart mooring in your operations?
Well, you know, the Persian Gulf, you know, some people might think it's, you know, it's an enclosed sea and it's not that, you know, it's not that subject to bad weather conditions, but it is. And between about late November, mid to late November through to May, I mean, we've just started June, and I've got the graph up next to me on my other screen, and it is showing that we're going to have some weather conditions coming in over the next 48 hours. So it generally, from late November through to May, we've got it on all the time. We're watching it closely. There's always some condition that's going to affect us. And during the summer months, the conditions are quite benign. So it's very rarely used, but all through the winter months, we're monitoring it all the time.
Yeah. And last question, you use it, you rely on it more and more. You said that's really good to hear. What would you say is the the added value piece of smart mooring for you as a harbor master, but also for Rakports on a whole?
Well, it's decision making, Baz. You know, it's to help us with our decision making, and decisions are always scrutinized when there's a commercial impact. And having a visual indication that we can circulate to show actually this is what we experienced on the berth, and we can back it up with the graph. Safety, of course, is paramount to us, but you know the harbour master always has to balance commerce and safety. So having something like smart mooring gives us a graphical representation. It allows us to improve our timings, because if you have a vessel that's alongside and it's been predicted that there's going to be some severe weather, we can work out exactly when to get it off the berth. We can watch the graph, see when it's going to shoot up, and it usually just does rise quite sharply. And you also have to understand the impact on the tugs, the pilots, you know, all the mooring lines. That if you know that the bad weather coming and you can get your timing just right, you can get the ship off the berth as safely as possible. We have had occasions where gangways have fallen down between the ship because of the rolling. It's then difficult to get a pilot on. Tug lines snatch. Tugs have to operate in certain conditions. So also, if they're pushing on, they're riding up and down the hull of the ship, and the fenders on the tug can get damaged. So it helps us with all of that. It's adding value right across the marine chain, and it also helps us to determine when to bring ships on. You know, we might decide to jump a ship in the queue and bring a Capesize on because the conditions are suitable. Or just get the timing right, so we can alert customers to when we're expecting things to improve, so that the whole logistical chain coming into the port can start working effectively. And it gives us an audible trail as well. That if you know that if you've got demurrage claims, and they can get quite costly, you know, we want to justify our decision making. As was demonstrated, you can go back in time. You can look at different events, and we can also use it as a training tool. So it does add value right across the board.
Thanks, Mike. That is good to hear, and I think very important, obviously, for your business as well. Also for you as a harbour master, concerned with the safety and operational aspects, but also with the business around you. I hear that you mentioned several of these elements that add value to you. What I also, for example, hear in one of the other ports is that they use smart mooring to bridge the gap where they actually want to invest in storm boulders. They say, okay, we don't do the temporary storm boulders. We make sure that we have better eyes on the location, and we can basically prevent the investment for those temporary storm boulders, but then be a bit more conservative on the on the decisions supported by a digital tool. So investing in digital rather than in hardware, that is something we see as well. Yeah, very much appreciated your time again. We work together very well. I really enjoy that ongoingly, and I know you're a strong supporter of us as a team, which is just cool. Thanks, Mike. We'll have a little bit chat afterwards, probably. Shall we move to the questions? Yeah, I think the time is 5 minutes left until 11. So are there some burning questions that needs to be answered?
Yeah, I think, Bas, if you would share the slides just to wrap up, to have some summary before moving to Q&A.
I can do that. So this was the Rakports thing. Yeah, so yeah, in summary, I think Mike McGee, Captain Mike McGee, summarized it nicely. Smart mooring software, it helps operator harbour master make more informed decisions. I think some examples were mentioned. It improves vessel scheduling. Also, like Captain McGee mentioned, to anticipate adverse weather conditions or the impact of ships rolling alongside or having the risk of breaking loose. You can anticipate and then take action. Reduce risks. Well, if you take the appropriate actions, you will reduce risks. and increase operational safety also by measures. And I mean, well, there's a various actions that can be taken. And Smart Mooring keeps listening to the market to say, okay, like the truck module that we're now building, that adds value to that operational decision. So that is something that we develop for the market, and then we can basically supply it to multiple of our customers using Smart Mooring if they want that features to be activated.
That was great. Thank you very much, Bas. Before moving to Q&A, can we please ask our audience the question on the next slide? What would you like us to cover next time? What other smart board topics? Please let us know that we could prepare a good content maybe in the autumn. So please share your opinion. Just enter your response.
Yeah, the answer may also be like, I want a specific webinar about the tuck module or so. It could be. Yeah, we have 3 minutes left. Maybe let's do some questions.
Yeah, so there's a question here from Ryder Harris. Ryder, interpolated from a pre-modeled database of solutions.
Yeah, that depends on the level of the software. And as I explained somewhere in the middle, right, we have level 1 is the vessel clearance model. That's static mooring analysis behind that. The level 2 is the industry ships, and that it's pre-modeled indeed. That is the so there's the answer is yes. And the third level of the software is basically there we model the exact ship that the client wants with specific given by the clients. And obviously all three comes with a difference in effort, right? So and the easiest to supply and have up and running quickly is the level 2. Level 3 obviously takes a bit longer to set up, in the order of 2 months or so, 3 months could be. Well, depends really on the scope and the wish of detail. But yeah, we can on the level 1 and 2 we can set up software quickly. Yeah.
Okay, and so Robert has asked, can this software be used to optimize mooring configurations as well as determining limitations?
I would give that one to.
Yeah, so in the future, as I presented, we are going to provide more configurability in the application so that the user can actually play around with mooring configurations. So that would be a way to optimize also for actual vessels being moored along a quay. So yeah, that is something that we probably will add in the future.
Yeah, and now you can play around with parameters in the vessel clearance model, right? There's a whole range of ships in there. Well, if you like to see how that works for your case, ask us and we can demo or provide you with a demo. If there's real interest from your side, we're happy to set up a thing, because we know seeing is believing. And in using really intrinsically being motivated to use it, that is the best convincer. So we're happy to facilitate that. Maybe a last question, seeing the time.
Yeah, so there's one more question here. How long are the simulations in the DMA if you forecast a full vessel loading window?
Alex, maybe full. Well, DMA. Well, I'm not sure what I understand the question fully, but dynamic mooring analysis is quite a heavy calculations. That calculation. That is also why we made these 3 levels, because in level 2 they are basically pre-done. On level 3 they can be custom made, and it's as I mentioned, the setup fee is if a setup period is then in the order of.
Yeah, so how far we can actually predict in time also really depends obviously on the forecasted mid-ocean conditions. So on the data supplier, so some data suppliers provide us with wind or with forecasted wind conditions on a 3-day basis, whereas other providers may provide us 5 days wind conditions ahead. So then we are also able to come up with predictions for those 5 days ahead. So that's also depending on the MedOcean input.
Yeah, by default we have 5 days ahead for our. Let's say we have if the port doesn't have a prediction, a weather prediction, then we can provide from one of our partners, DTN actually, for wind and I mean, as Mike McGee mentioned, StormGeo has the wave prediction 14 days ahead, but we start to show them only 5 days ahead. But mostly we hear that 1 or 2 days ahead, these decisions become relevant. And also, I mean, the prediction more than 5 days ahead is quite inaccurate. So that's the order. Yeah. It's well, if people are leaving, please leave. Well, we do a last question or not? Or should I wrap up? Wrap up. Okay, I'll wrap up. Thanks for your attention. Probably people will be leaving now, and it was good to see that our guest, Mike McGee. If you want to know more, you can reach out either to me or via the Twinn.io smart mooring website. If you see yourself as a potential user, we can set up a demo environment for you, and you can give it a try. We're very happy to facilitate that. So thanks, Koos, thanks, Alex, thanks, Olga, thanks, Captain Mike McGee.
Yeah, maybe we can add that because there were some other questions in the chat as well.
Yeah.
So let us promise that we will come back on each single question that has been raised in the chat.
Good.
So we'll come back on that absolutely.
Yeah. So indeed, right.
Yeah. Thanks everyone. Thank you for participation and your time. Have a good day.
Yeah. Thank you so much.
Thank you. Thank you very much. Cheers.
Yeah. Thank you.
All right.
Thank you, Alex. Cheers.
Thank you, guys.